Hey everybody, in this video we're going to talk about the distributive property with radicals. If you recall, the distributive property says that allows us to multiply a number by a sum or a difference by multiplying each part of that sum or difference and then adding later. This is really going to be no different when we're dealing with radicals. The challenging part is going to be simplifying those radicals. So we're asked to simplify this problem, square root of 6 times 3 minus 2 times the square root of 2. So in order to do this, we are just going to distribute this square root of 6 into our terms in our grouping. So when we do that, if we rewrote this out, we now have the square root of 6 times 3 minus the square root of 6 times 2 times the square root of 2. Over on this left side, can we simplify the square root of 6? Well, we can't because 6 doesn't have any perfect square factors. There's nothing to break the 6 down and simplify it further. So we can't do anything there, and there's nothing to multiply the 3 with, so it's just going to stay the same. I am going to change the order. Standard form has us write the number first, followed by the square root, so it becomes 3 times the square root of 6. Over on this right side, here we have the square root of 6 times 2 times the square root of 2. If you recall, the product rule of radicals allows us to multiply these two values under our square roots together to combine into one square root. So I'm going to move that 2 out front again, and then it becomes 2 times the square root of 6 times 2, which is 12. So now we have 3 times square root of 6 minus 2 times square root of 12. We can't simplify the front, but how about the back? Can we simplify this right side? 2 times the square root of 12. Can 12 be broken down into two factors, one being a perfect square? And it can. We know that a factor of 12 is 4, and 4 is a perfect square. So we can break this down into 2 times the square root of 4 times the square root of 3. Right? We just took the square root of 12 and broke it down into 4 times 3, which is 12, and split it apart. We're able to do that with the product rule of radicals. Well, we know what the square root of 4 is. That's 2. This 2 stays the same. Everything else comes on down for the ride. So now out front, we can simplify 2 times 2. That is 4. And then the square root of 3, we cannot simplify because the square root of 3 doesn't have any perfect square factors. The front didn't change at all, so we'll just bring everything down here. So we have 3 times the square root of 6 minus 4 times the square root of 3. And that is your simplified form when distributing using radicals.